In 1662, an Englishman Boyle was doing some experiment of low pressure gas contained in a vacuum tube. So he was studying relationship between pressure of the gas and its specific volume. Here specific volume means volume per kilogram of gas. So its unit is meter cube per kilogram. And the gas inside this vacuum tube was a low pressure gas. And from his experiment he found that pressure varies inversely with specific volume. Later on in 1802, Charles and Boyle and Gay-Lussac found that specific volume is directly proportional to temperature of this gas. This temperature is absolute temperature. Absolute temperature. That means this temperature is always expressed in Kelvin, because Kelvin is an absolute temperature scale. Now from these two equations we can say that pressure is directly proportional to temperature and inversely proportional to specific volume. Now if you remove this proportionality constant, then you will get a proportionality constant. This R is a gas constant. Now value of R is dependent on what type of gas is it in this vacuum tube. Hence we can write this equation PV is equal to RT. Now let us say mass of gas inside this vacuum tube is M. Now if we multiplied, or let us say we can express specific volume is equal to volume of this vacuum tube divided by mass inside the gas. So we can write this expression of specific volume inside this relation. So we will get volume upon mass. So finally we will get PV is equal to MRT. Now this equation is called ideal gas equation. And gas which follows this equation is called an ideal gas. This equation is also called equation of state. Equation of state. Because from this equation we can know pressure, volume and temperature of the gas, and from these three variables we can define state of the gas. Actually ideal gas is an imaginary concept. No practical gas or no real life gas can be an ideal gas. This is because let us say we have volume V, and in this volume we have gas molecules, and between these two molecules we have cohesive force. Hence, due to this cohesive force, real gas deviates from ideal gas behavior. However, if we keep pressure of the gas in this volume reasonably low, very low pressure, and temperature inside this volume, means temperature of gas we keep very high, then we will have a very low density inside this volume. So there are very less particles inside this volume V, and because of this, distance between two nearest particle will increase. So compared to this, we have less density here. That means less particles inside the volume, and hence large distance between two gas particles. And hence, because of large distance, cohesive force decreases or it is negligible. Hence, in these two conditions, if a gas satisfies these two conditions, then it behaves similar to an ideal gas. Similar to an ideal gas. So for example, steam in boiler or steam turbine. Steam. So in steam turbine, we have steam at very low pressure and high temperature. So in this condition, we can apply ideal gas equation to this steam. Also, air behaves as an ideal gas because our atmospheric pressure is low and the absolute temperature is relatively high. So we can apply ideal gas equation PV is equal to MRT to the air in room condition. Now we will write this equation in terms of moles. Now scientist describes number of particles inside a volume, not in terms of number of particles but in terms of moles. So let us say we have a volume V, and in this volume we have n kilomoles or k moles of particles, n k moles of particles, and mass of this gas is m kilogram. And for this particular gas, let us say molar mass, that means mass per number of moles. Mass per moles. We have m. Its unit is kilogram per kilomole. So we can say that mass is equal to molar mass times number of particles. This is because molar mass is kilogram per kilomole and n is kilomole. So this will cancel out and we are left with kilogram, which is unit of mass. So we can write this equation. M is equal to molar mass m times different gas has different molar mass m. So we can write value of m inside this equation, and hence we will get m is equal to nm. Now this mr is a constant, and this constant is called universal gas constant, whose value is 8.314, and its unit is PV is unit of work, so it is kilojoule per kilomole, and unit of T is Kelvin because it is absolute temperature. So its unit is kilojoule per kilomole into Kelvin. Now for any gas, the product Mr is a constant. So let us say we have two boxes of same volume, and in one box we have helium gas and in one box we have nitrogen gas. So M1 R1 and here M2 R2. So we can write M1 R1 upon M is equal to M2 R2. So this is important relation for the GATE exam. Now finally we can put Ru in place of Mr. So we will get nRuT. So this is the state of equation in terms of kilomole, in terms of moles of the particles. So this is equation of state in terms of moles of particles.